Okay, now for our third example, we'll differentiate the function y equals x cubed, a slightly more complicated polynomial using the difference quotient. Here is the difference quotient. We'll just remind ourselves, and then we'll write that out. We have the limit as, that should be h goes to 0, of x plus h quantity cubed minus x cubed all over h. And then let's multiply that binomial out in steps. So we'll go x plus h times x plus h squared. So that's x plus h quantity times x squared plus 2xh plus h squared. Got our minus x cubed out there, all over h. And then we'll multiply these two monsters together. That'll give us 7 terms in the top. Okay, that looks about right. And then we notice right away that we can cancel these x cubed terms. And now let's just do a little bit of bookkeeping, and let's rewrite this and group the like terms together. There's going to be terms with hx squared and terms with x squared h, and then that h cubed term left. So I'm just kind of checking these off as I rewrite them and combine them down here. That's that, and then I just have that h cubed term all over h, and now I see that there's an h in every term, so I can cancel one h out of every term, and then just rewrite my limit as the limit as h goes to 0 of 3x squared plus 3hx plus h squared. And then as the h goes to 0, I'm just left with 3x squared. So that's our derivative. Now let's graph both of these functions and see what they look like. The function x cubed, we recognize this as a parent of all the cubic functions. It's just this sigmoidal function. And its slope is positive everywhere. It's always pointing upward and to the right. And the derivative is, of course, just a parabola that's steepened by that factor of 3, so it's a steep parabola. Now let's take a look at the function. The function has an inflection point, so we know its slope is 0 right there in the center, and indeed the derivative goes through 0, so that makes a lot of sense. And of course the derivative is always positive, as is the slope of the original graph, so that makes sense. So all things considered, this looks reasonable for the derivative of the function f of x equals x cubed, where the derivative is positive and increasing in slope, so is the function, and where the derivative is positive but decreasing down to 0, that's what happens to the slope of the function. If we just draw it in here, we can see that the slope is approaching 0 there. So our derivative of the function f of x equals x cubed with respect to x is 3x squared.